So basically what you first do is, what I first did is I looked at the alpha parts. So if there's an alpha linkage, what does that mean with the two glucose molecules and the orientation of the hydroxyl groups?
Isn't it like a bond with all hydroxyl groups on the outside? Isn't that what it is?
Yeah, so for an alpha and a beta glucose, have you seen how the two link yet?
Yeah, doesn't like the beta fold into it? No, actually I have no idea, but honestly, no clue.
Okay.
That part doesn't make any sense.
Yeah, here. Can I borrow your pencil?
Yeah, go for it.
Okay, I don't know how to do this. Okay. Yeah, so basically you start by numbering. You look for, like, there's going to be an oxygen group on the glucose molecule, and then right to the clockwise of it is the first carbon, second, third, and fourth, and fifth, and then this is the sixth. So you look at the 1 and the 4, and there's a 1 and a 4 here. And they both will have hydroxyl groups, and depending on whether it's alpha or beta, the hydroxyl groups will be oriented. So the alpha has the hydroxyl groups oriented down, and the beta has the hydroxyl groups oriented, do you know which way?
They're like on the inside and up.
Yeah, so one of them's up and then one of them's down. Like that. So that's how the beta one is. So for the alpha linkage, the two are going to link. If you have two alpha linkages, then you'll have like two hydroxyl groups kind of coming down together, right? Okay, so then this is going to link, and then it'll become like that. Have you seen that through the dehydration reactions? Okay. So basically this is an alpha 1,4 linkage, because when you look at the two carbons that have the groups forming the bonds, you look at the carbon that's the 1 carbon, because this is the 1 and then this is the 4.
Connected to the 4?
Yeah.
Gotcha.
And so
it's A on this one. It's connected down
yeah,
from the
so
1 and then up to the 4, and the hydroxyl groups or hydroxide groups are not one down, one up.
right. So why would it not be B?
Because B, they're facing up, and then
Right.
it's like a 1 to 2.
Right. Or that's still a 1 to 4.
Is this still a 1 to 4?
No, okay, see, that would still be a 1 to 4 linkage, because these are both beta molecules, most likely. And so the way that they're gonna align, like, upwards is if one of them flips over. But it's just flipping upside down. So, like,
So just flip it.
so like this is still the 1, and that's because of the way it's flipping. The 1 still kind of rotates the same way. So that would still be a 1,4, but it wouldn't be an alpha. What about number C? Why would that not be the
Connected weirdly. It's higher than the other one.
Yeah, well,
One
that
of the hydroxyl groups is up, the other one's down.
right. So immediately you know that's not an alpha
Same thing with B,
molecule.
one's down, one's up.
Yeah, and the reason those interactions do exist, it's called an alpha 1,6. Or yeah, it would. Or sorry, I think it's a beta. Yeah, beta 1,6, and it would still be. Like that's still a legit molecule, but the reason it's a 1,6 is because that's the 1 carbon, and then it's attached to the 6 carbon on the other one.
Gotcha.
So, anyways, does that make sense?
Yep.
Okay, awesome.